All right, we're going to begin talking here about the start of Chapter 10. This is called Making Predictions in Lesson 1. But really, this builds upon a lot of what we did in Chapter 9. You could really call this chapter a chapter on statistics. You're going to see here in this first lesson that we're going to take a lot of probabilities and then talk about when populations increase. And so you're going to see some of these terms show up here. So statistics deals with collecting, organizing, and interpreting data. You might ask your parents. They may have taken a statistics class in college. Often you might take that as your math requirement. And a lot of people think it's really pretty challenging stuff when you're looking at things like surveys. So a survey is just a method of collecting data. And when you survey a group, that's often the population. So a group being studied is the population. And then a part of that group, which is usually who the survey would go to, that's a sample size. But the sample and the population have some similarities. If we would survey 10 students at Edgewood Junior High about their interest in something, we might be able to take the same 10 and kind of represent the whole school out of that. So we'd take the 10, which is their sample, to represent the whole population of the school. All right, so let's just jump in here to these examples. So in example 1, it says a survey found that 6 out of every 10 students have a blog. What is the probability that a student at the school has a blog? So just randomly, picking students out of a roster, what's the odds that they're going to have a blog? So really we're asking, what is the probability? And there's not really a whole lot of work in this question. We have to put it in 3 different forms: fractions, decimal, and percent. So as a fraction, we really just write the 2 numbers that I'm given here, the 6 and the 10, and we write those as a fraction. And then I would divide top divided by bottom. 6 divided by 10 would give me 0.6. So that's going to be my decimal. And then as a percent, it would end up being 60%. So we move it 2 places to the right when we multiply by 100. So any of these answers, obviously it asks for all 3, would be acceptable, but 6 out of 10 is the probability. Reduced into the lowest terms, that would be 3/5. And then we would divide either 6 out of 10, 6 divided by 10, or 3 divided by 5. We get that 0.6. And then finally we multiply by 100 to say that that's 60%. So more students have a blog than don't have a blog, right? 40% do not have a blog, 60% do. And so now question 2 just says, suppose that 250 students are at the school. How many have a blog? So this is where we take what happened in our sample of 6 out of 10 and we increase this to show what's going to happen out of 250 students. So one way that we would do this is by using something that we've already talked about before, where we set up proportions. So we could have 6 over 10 set equal to x, the part we do not know, out of 250. Because remember, not every student, not all 250 are going to have a blog. So we would do cross multiplication. That would end up being 6 times 250, and then we would divide by 6. There is another way of going about this problem. I'm just going to show you this because it comes up a little bit later in a different example. But you wouldn't have to set up a proportion. You could take what we had in the previous slide, that this is representing 60%, which is represented by 0.6. We could take that and we could multiply that times 250. You would get the same answer. So either method here would be okay to get you the right answer. You're going to see on the next slide, whenever I move on to it, that I use the proportion method, but there, either one of those would work. So here we go. A little bit kind of hard to read because I had to copy and paste this. So we see 6 out of 10 equals x out of 250. Cross multiply there. 6 times 250 is 1500. And then we have 10x equals 1500. Divide both sides by the number in front of the variable, which is 10. And so that gives us 150. And for these problems, we really should label our answer because it's asking for how many students. So 150 students, if you think about that, remember I said it's more that do than don't. So half of the population of 250 is 125. So 150 is definitely over half. So the remaining part, which is 100 students, do not have a blog, but most students in this scenario, in this example, have a blog. So 150 students is our answer for that. Now we're going to take a look at a circle graph. And in this circle graph, this is the result of children ages 8 to 12. We're asked whether they have a television in their bedroom. And so we have 54% say that they do not have a TV in their bedroom, and 46% say that they do. So the question here says, predict how many of the 1,725 students would have a television in their bedroom. Two ways we could go about this problem. We could either set it up as a proportion, which would be now how many students are originally in the survey. Well, since it's based on percentages and our percent is always out of 100, what we can do for this is we're concerned with how many do not have a television, so that's 54. So I could do 54 over 100 equals X, which is our portion out of the total number in our full population, which is 1,725. One way to go about it. The other way to go about this is to just use the percentage that's given, which is 54%. So I could just take 0.54 and multiply that by 1,725. And the second method here is what you're going to see that I've already done on the next slide. So let me go back. I can only annotate whenever I'm out of the presentation mode. So you'll see there that I multiplied 1725 times 0.54, 54%. So we get 931.5. Now, one thing I want to talk about here is that really this answer is not acceptable for a couple of reasons. One, it's not labeled, so it should be. Another reason that it's not a good answer is that we have 0.5 students. Well, that's not really possible. That's half of a person. Based on averages, we see that a lot in our grades. You might get a 99.3% in a class, but you can't have 0.5 of a person. So a lot of times in these types of problems, a lot of times in problems in general, we get in the habit of rounding up. This would not be a case where you would want to round this up because you're not actually going to have 932 students. It would be 931. So the best answer here is to actually round this down. It's kind of contrary to what we usually talk about, but I would say for that one, the best answer is 931 students because it's not high enough. 54% is not 932. It's halfway in between 931 and 932, and so we're going to round down in that example. So 931 students is the best answer. So for this next one, now we're just changing the number of the population. So now it's 1370, and we're after have a television in their bedroom. So now we're looking at 46%. So I could set up a proportion again, or I can do it like I did here, 1370 times 0.46, and we get 630.2. Now this one again needs to be rounded. I think it makes a little bit more sense here because it's not halfway in between, but since it's 630.2, we should really round down. It's closer to 630 students. Even if it was 0.9, I would still say you should round down because it hasn't hit that next number up there. So the rounding with this stuff is a little bit interesting. I haven't looked too much at the assignment to see what those answers are, but you need to try to pick not only which one it's closest to, but which one makes sense because you can't have that another full student here when we only have 0.2. So 630 students have a television in their bedroom. And that is our last example. So I flew through that pretty quickly, but you're going to see a lot of this either setting up proportions or using a percentage in a population to show what would happen with a larger group. So thanks for tuning in. Hopefully that helped you. Thanks for watching.